Good day, everyone. I'm Ria Ganayo, and I will present my proposed thesis improving shelf life characteristics of brown rice using polarized infrared heat treatment machine. Background of the study. Rice is the most important staple food crops, especially in Asia. With expected population growth, the demand for rice will continue to increase. Rice grain processing steps such as drying, milling, and packaging after harvest is convenient for general consumption. Drying a grain to below the critical moisture content is one way to control or prevent the microbial growth on rice during storage. When the bran layer is exposed to external environment, enzymatic activity may increase and cause the acceleration of lipid degradation during storage period, which reduces the sensory quality of rice. Infrared technology with high energy efficiency can be an effective disinfection method for brown rice. It can avoid the effects of changes in color, texture, aroma, flavor, and nutrients of grain. Rice is usually dried with hot air for a high drying rate and milling quality. Nevertheless, the economic way to improve the shelf life of brown rice is to inactivate the lipase enzyme to minimize the lipid oxidation, which cannot be achieved using hot air drying. Statement of the problem. Brown rice has a short life of about 2 to 3 months. Despite having a nutritional value, brown rice is not widely consumed and marketed. The main reason of it is the timeline between its production and usage. If the lipase enzyme in the outer layer of rice is exposed to oxygen, it will produce free fatty acid by the action of very active lipase enzyme that causes rancidity. To extend the shelf life of brown rice is to minimize lipid oxidation by deactivating the lipase enzyme of the bran. There are two objectives of the study. The first one is determine the characteristics of infrared treated and untreated brown rice in terms of moisture content and degree of rancidity indicated by the free fatty acid or FFA. The second one is determine and analyze the changes in sensory attributes of brown rice upon the storage. Significance of the study. Brown rice is a shorter life because it is not polished. It has a higher fat oil content, therefore it may become rancid more quickly than the white rice. Brown rice may give off a rancid odor and become oily because if it's fatty acids that break down as they oxidize. The FFA in brown increases more rapidly with higher moisture content. Therefore, the rice bran must undergo a stabilization process after milling. To inactivate the potent lipase enzyme and control the FFA concentration at a low level before oil extraction, extending its storage time at ambient conditions. Infrared treatment, a method to improve the shelf life of numerous commodities, especially grains. It is an effective process for the inactivation of lipase that is responsible for the rice bran degradation and instability. Enzymatic inactivation of lipase in grain decreases the stability of rice during storage. Here are some review of related literature. Brown rice is an unpolished, whole grain rice that is produced by removing only the husk or husk. And the brownish coating of the whole rice grains contains high nutrients. During rice milling, the removal of bran and germ results in nutrient losses, which contain a high amount of fiber, minerals, protein, and especially substantial B vitamins. The major nutritional advantage of brown rice over milled rice is its higher content of B vitamins. Because rice that has been polished loses more than 80% of its thiamine content that enables the body to use carbohydrate as energy. Infrared heat treatment. Rice is typically dried using either hot air for a faster rate of drying or ambient air for a higher milling quality. However, due to the low temperature, these methods are unable to inactivate the lipase enzyme compared to infrared radiation that has the potential. Infrared radiation is a type of electromagnetic radiation that lies between visible light and microwaves in the electromagnetic spectrum. The electromagnetic spectrum of different types of radiation, including infrared. The wavelength of far infrared rays for industrial use has a range of 2.5 to 30 microns, which overlaps with the molecular vibration range of many materials as shown in figure. The mechanism of heating by far infrared rays is when far infrared rays are absorbed on a material surface. The molecular vibration is activated, causing the material temperature to rise. Residity and free fatty acid. Hydrolytic degradation of lipid causes acidity in brown rice. Brown rice is relatively stable because lipolytic enzymes are primarily found in the cross cells of the bran, while the majority of the oil is stored in the allular layer and germ of intact rice kernels. This physical separation is disrupted during milling, and the lipase enzyme comes into contact with neutral fat, causing fat hydrolysis to FFA and glycerol in the bran. Free fatty acid content, which is a sensitive indicator of quality changes, is frequently used as a measure of stored grain deterioration. An increase in FFA content in stored grain has been observed during the storage process, which is attributed to the role of lipase hydrolysis. This can have an effect on the texture, flavor, composition, and eating quality of rice. In general, FFA levels rise with storage time, while grain quality declines at the same time. When the FFA content of grain reaches a certain standard, it deteriorates and becomes inedible. Lipase activity. Although lipids are not as abundant in rice as a carbohydrate and protein components, they are critical because they contribute to the nutritional, sensory, and functional qualities of the grain. The acidity of the lipids in brown rice is well known as a major deterrent to the widespread use of brown rice. Furthermore, lipids associated with the starch component have been discovered to affect starch passing and other functional properties. Rice lipids have considerable influence on rice quality, and lipid constituents in rice byproducts may have important value that provides medical or health benefits. Methodology. Conceptualization of the study. Exposing brown rice to infrared heat treatment can improve its shelf life characteristics prior to storage. After various length of exposure, brown rice will be cooled at room temperature and be packed using vacuum-sealed bags to store in a cool, dry place. This is my conceptualization study. Input: untreated brown rice to infrared heat treatment, and the output is infrared heat treated brown rice. Input: optimization treatment trials of infrared treated brown rice. Then the process is chemical test to evaluate the characteristics of brown rice. And the output of this is optimum treatment for shelf-stable brown rice. Input: stored samples. The process is sensory evaluation, and the output is general acceptability. That's all. Thank you for your time.